Yo, Chuck.
What the chuck is up, YouTube? In this video, we're going to go over selection sort. Selection sort is a sorting algorithm that searches for the minimum elements in an array and then performs a swap each iteration. So the first half of this video, I'm going to visually explain how selection sort works, and then I will finish off with a coding example. Okay, let's get started. Alright, so here's my unsorted array of numbers. I need to sort them in ascending order using selection sort. So how does this work? Well, I'm going to start at index 0, and that is the very first index I'm on, and I'm looking for the smallest number after index 0, which is I, because I is going to be where we start. So I'm saying the minimum so far, I'm initially setting it to the value of I. So right now I is equal to 0. I'm going to scan the numbers that are not located on index I and check for the smallest value. So I see 4 is smaller than 5, 3 is smaller than 5, 1 is smaller, and then 2 is smaller. So because 1 is the smallest, I'm going to record that value. So I'll say the min is at index 3 because that's where 1 is located. 0, 1, 2, 3. And actually, just to make it more clear, I'm going to write the value so you know what value I'm looking at as well. Let's center that. All right. So since we found the minimum value of 1, we can now perform that swap. So I'm going to swap 1 with 5, just like that. And let's do another iteration of our loop. So this time around, we're going to change I. It's going to increment by 1. So now I is going to be right here. Again, we reset our minimum index value. So I'm going to say this is going to be equal to 1 at the start, and that is 4. Okay? So our minimum value is 4. We need to look for something smaller than 4. We find 3 and 2. 2 is the smallest. So we can say the smallest value is located on index 4 because that's where 2 is located. 0, 1, 2, 3, 4. And that is a value of 2. So now that we've performed this loop, we can swap these values. 2 swaps with 4. Okay. I go down here. I is going to increment once again. So I'm going to increment I by 1. All right. Now I'm going to scan the numbers to the right of I, which are 5 and 4. Neither one of those numbers is less than 3. So our min is actually located on index 2 because that's where 3 is located, and it's a value of 3. So I'm going to scan the array another time. Here we go. We're going to increment I yet again. I becomes this value of 5, and it is the minimum value at the start. It is located at index 3. And we're just going to scan, is 5 greater than 4? Is 4 less than 5? Yes. So we're going to perform that swap. I'm going to first mention that the min has been updated to index 4, and that is a value of 4. So now I can perform this swap 4 and 5. And now our array is sorted. So that's all there is to selection sort. We're just hunting for the index of the minimum number that is not located on index I, and just scanning through the numbers, finding that small number, the smallest, and then swapping it with I, each iteration of our loop. Okay, now I want to hop over to a coding implementation of selection sort. Okay, so the first thing I'm going to do is come in here and make a function like we always do. I'll call it selection sort. I'm going to pass in an unsorted array. For now, I'm just going to return that array. And let's console.log the function call of selection sort. I'm going to pass in an unsorted array, something like this. And let's see what happens when I run the code. It returns the array. Okay, perfect. So like I mentioned before, we're going to first loop through this array. So I need to do just a standard for loop. So I'll make a variable called I. I'll set it equal to 0. As long as I is less than array.length, I want to increment I. And recall, at the start of every implementation or every firing of this for loop, I want to record the minimum value index, which initially I'm going to set to I. So I'm going to make a variable called min and set it equal to I. So this records the position of the smallest number, and recall that I'm setting the smallest number initially to array at index I. So 5 right now is my smallest number, but I need to find, is there any smaller numbers in this array that could replace the position of 5? So to do that, I'm going to make a nested for loop. So I'm going to come in here and say for let j equal I plus 1. Why do I say I plus 1? Because I never want to compare the value of array at index I with itself. I need to start with the next value over at the beginning and then go to the next value and then go to the next value and then go to the next value until I reach the end of the array, at which point I'll be like, okay, well, 1 was the smallest number in this scan through, and 1 is at indices or index 2, so I know min should be updated to 2. Okay? So just the same logic here for our inner for loop, increment j. Right, so we're looking for that smallest number in our scan through, and our scan starts 1 plus the position of I. So it's going to be these numbers at first. Then once I increases, it's going to be these numbers. Then once I increases, it's going to be these numbers, and so on and so on. So I'm going to say if array at index j is less than array at index min, because remember, min is initially always set to I at the start of each firing of this outer for loop. Okay? If that's the case, I want to update min. So we'll say min equals j. And then now I'm going to exit out of this inner for loop because I will have captured the index of the smallest element, okay, after I, and then I'm going to perform a swap. The way I'm going to do that is first make a temp variable. This temp variable is going to store the value of array at index I. Next, I'm going to set the value of array at index I equal to the value of array at index min, whatever that is. And then finally, I'm going to perform the swap by setting array at index min to that temp variable. And there you have it. That's pretty much all there is to it. Let's return the array to make sure it's sorted. And it looks good. So let's kind of just walk the dog for like the first couple of iterations or so. So I'm actually going to just console the array to see what happens, what it looks like. Okay, so we're starting here with our unsorted array, which is the same as our input. All right. Now the first iteration, it's going to look for the smallest number. We're starting right here. So we're going to look, is there a number smallest? What is the smallest number? It's 1. So we do a swap of 1 and 5. Okay. And actually, it might be easier to understand if I also console log the value of I. Okay. So now we know where I is, right? So now I is at 1. So that means we're starting from here, and we're going to scan these 3 numbers and look for a number smaller than 2. There is no number smaller than 2, so this will remain unchanged. Then we increment I one more time. Now we're at index 2, which is 5. And we're going to scan these 2 numbers. What is the smallest number of these 2? That would be the 3. That's at index 4, so min is equal to 4. We perform the swap of these 2 numbers, and now we have this array, and we're at index 3, which is the number 5, and we're just going to scan up until 4. Is 4 less than 5? Yes, it is. We perform this swap, and then we're left with a sorted array. So that's basically how selection sort works. It's not too complicated. Just remember you're hunting for that index of the number that's lower than whatever I is, and that's the logic right here. And also, just make sure when you're doing your swap, this is in the initial for loop, right? It's not in the nested one. So that's an important distinction to make. Also, it's worth mentioning that selection sort has a time complexity of O of n squared. I hope you guys enjoyed this video. Be sure to like and subscribe. I will see you in the next one.